51 and 62. It's pretty basic information. Stuff that a lot of this you should already know how to do. You look at question number 1 up here. It says find the range, mean, median, and mode, variance, and standard deviation of the following. Most of that you already know. What is range?
The smallest number, the distance from the smallest number to the largest.
Right. So you find the largest number in the data. If you subtract the smallest number, that's going to tell you what your range is, correct? All right. So we could look through here. All right. Our largest number appears to be, what, 24? Our smallest number appears to be 5. 24 minus 5 is, what, 19? 19. So we would say we've got a range of 19 here, correct? Okay. All right. Let's see, actually, maybe include that. What is mean?
The average. You take all the numbers out of it, find it.
Right, take all our numbers, add them up together, divide by however many numbers there are. So that's our mean. What's our median? So take our data set, order it from least to greatest, find a number in the middle. What if there's an even number?
You add those two, divide by 2.
You find the two numbers that are in the middle, find the average of those two. Yes. Okay, and what is mode? The number that occurs the most often. So in this case, we should be able to look at that data set and see which number occurs the most. What number is it going to be? 24. The two that people kind of struggle with the most are variance and standard deviation. Okay, now there is a long process for finding standard deviation. Okay, and I'll show you what that is, and fortunately, I'm going to show you the much quicker way to do it, which is plug it in your calculator. But just so that you understand what it is, all right, after we find the mean, right, the first thing that you have to have in order to find standard deviation is you have to have the mean. In this case, after we've done all the work that we would do to find the mean, we're going to see that the mean is 17 in that data set. So what we're going to do after we know that the mean is 17 is we're going to go through each number that's in the data set. So like our first number is 5, and we're going to do 5 minus 17 squared, plus our next number would be 8 minus 17 squared, plus 13 minus 17 squared, plus 17 minus 17 squared, not because, well, I mean, it's just what 17 is in our data, plus 18 minus 17 squared, plus 21 minus 17 squared, and it would go on, let's see, plus 23 minus 17 squared, plus 24 minus 17 squared, plus 24 minus 17 squared. So what this is doing is it's finding the distance between each number and the mean and adding all those distances together and then dividing by however many there are. In this case, there's 9. So what standard deviation is, it's finding the average distance of every number in a data set from the average. Does that make sense? Okay, now that's a really long process to go through, and it would give you your standard deviation. Variance is going to be, let's see, what do we get out of this? And so it actually, at the very end of that, you end up square rooting it to get your standard deviation. What I'm going to show you is how to do this in our graphing calculator to get all of this data without having to actually calculate anything. The only thing that you might have to calculate would be mode, which mode is going to be easy to find anyway. All right, so let's go back to this page over here. Hopefully a lot of you guys already remember how to do this. How many of you remember how to plug all this data in and get it? Okay, so good. So we're going to hit stat, which is going to give us our list. We're going to hit edit. We want to make sure that everything is already cleared out. You can do that quickly just by hitting delete on any numbers that are in there, or we can go back into stat. We can come down here to number 4, hit clear list, And then what we would do is we'd hit second 1 and possibly second 2. And that would, we'd hit enter. And that would clear any list that we had in there fairly quickly. If you had a bunch of data, that'd be the quickest way to do it. Does that make sense? Does everybody in here have a graphing calculator to work with today? Yeah, I still have yours plugged in, Samira. Okay, so we're going to hit stat. We're going to edit. We're going to go through here 17, and I don't have to reorder the data. It's going to do that for me. 17, 18, 8, 5, let's see, 21, 23, 24, 13, 24. Okay, then we're going to hit stat again. We're going to come over to calc, and we just want one variable statistics. We just want the statistics that come with this. Sometimes you, on a newer calculator, you may have to hit enter several times before you get down to all of your data. So what I want you to see here is this X with the line over the top of it. That represents mean. Okay, so we should see that our mean is 17. Did everybody get that? All right, so it's not going to say mean. You're going to have to know that that is coming out as mean. This symbol right here is sigma x, and that is my standard deviation. So my standard deviation here is 6.6. Okay? Now, what this won't give me is it will not give me variance. Okay? It won't give me variance. So what I end up doing with my standard deviation in order to get variance is I'm going to take 6.6, or if I really want to be thorough, I can take it further on out. I could take all of this. But to get variance, variance is your standard deviation squared. Okay? Your standard deviation is the square root of your variance. 43.56 is your standard, or sorry, is your variance. Now, if we go on down through here, we can hit this arrow, and we can get the median. The median is 18, right? And we already knew by looking at the data that the mode was 24. So we have mean, that was given to us. Median, we went down and we found. Mode, we could find by looking at the data. Standard deviation, we got 6.6, right? And we could take 6.6, square it to get my variance. Does everybody understand how we find all of that data? Okay?
How do you want to show work on, like, say that question popped up on the test?
For the most part, it's just going to end up being in your calculator, and I understand that and know that to be the case. Keeping in mind that your tests are not multiple choice, so you can't just pull those numbers. You know, if it's not multiple choice, you're not going to be able to pull those numbers out of your butt. You know what I mean? You won't just know it, right? Because obviously the numbers are going to be different than the numbers on your review. So it's a little different than, say, an Algebra 2 or a geometry test where you've seen this exact question before and you automatically know it, right? So I'm not really concerned about that. And I'm not, you know, if I really wanted to be anal, I could make you show me how, you know, you got variance and standard deviation. See, what you're getting up here, this number is going to be your variance, right? This is going to give you 43.56. And in the end, you're going to square root that 43.56 to get standard deviation, which is going to be 6.6, right? So this is how you find variance, and then we find standard deviation by squaring all of that. Okay? All right, hopefully we're good there. So with that, before we move on, what I want you guys to do is I want you to find the answer to question number 2. And I'm going to hit pause on the video here so we're not chewing up a bunch of time there on here. All right, question number 3. This is what we call normal distribution. Again, this kind of builds on that same concept. Number 3 says the mean of distribution is approximately 125. The standard deviation is 13. We're going to use the standard deviation to tell how the data are distributed with respect to the mean. So we're going to come over to this page here. We'll erase this. I'll show you how this information is used. Okay, so the first thing we're going to do is we're going to draw a line, and they tell me what the mean is. They tell me that the mean or the mean of the distribution is approximately normal is 125. So 125 is going to go right here in the middle. Okay? So the mean of distribution always goes right in the middle of our line. You follow me so far? All right, the next thing that you want to look at is what is the standard deviation? The standard deviation here is 13, which means I'm going to go 13 above and 13 below, and that's one standard deviation from 125. Okay, so what is 125 plus 13, and what is 125 minus 13? 138? 138, no, and need to subtract 112. Okay, so this is one standard deviation. All right, and the thing I want you to understand about this is that one standard deviation will always be 68% of the data. All right, so we're going to put a 68% right there. Follow me? Okay? All right, now, let's see. We, I believe, did this or showed this towards the end of Algebra 2. All right. The next, now we want to go another standard deviation out. So we're going to take 138 and add 13. 151. Okay, and we want to take 112 and subtract 13. 99. Okay, now that's two standard deviations, and two standard deviations will contain 95% of the data. Okay, and then we're going to go another one out. So we're going to take 151 and add 13. 164. We're going to take 99 and subtract 13. 86. And I'm kind of running out of space here. Okay, but three standard deviations will contain 99% of the data. Okay, so this is our answer to this. We have one standard deviation, two standard deviations, three standard deviations. Okay, does that make sense to us? And these percentages will go with those. 68, 95, 99. You need that for your answer. You have to know that those percentages go with that. Okay? All right. Now, let's look back at another question. Number 4. The test scores were normally distributed with a mean of 57 and a standard deviation of 4. They want to know approximately what percentage of the scores lie between 53 and 65. We want to use a standard normal table. So we're going to go back to this. You're going to hold on to this. We're going to redraw this. All right? So because this is standard, all we really have to change here are these numbers right here. Okay? What was my mean of distribution? 57. So I'm going to write 57 here. What was my standard deviation? 4. So I'm going to do what as I go to the right? Add 4. 57 plus 4 is 61. Okay? 61 plus 4 is what? 65. Okay? And 65 plus 4 is 69. Okay? All right. 57 minus 4. 53. 53 minus 4, 49. Okay, and 49 minus 4 is 45. Okay, now let's go back and look at the question that they were asking. Okay, the question that they asked was, what percentage of scores were between 30, oh, I'm looking at the wrong part here, between 53 and 65. Okay, between 53 and 65. Well, if they had said between 53 and 61, we would have said 68%, right? But it didn't work that way. 53 and 65, so it's a combination of one standard deviation and half of the second standard deviation, right? Okay, so this is what we do. We're going to take 95, and we're going to subtract 68. Okay, 95 minus 68, what's that equal? 27. Okay? We're going to take 27 and divide it by 2. What's that? 13.5. Okay? Because we're getting all of 68, right? But we're only getting half from 68 to 95. So we're going to take 13.5 and we're going to add it to 68. Okay? What's 13.5 plus 68? 81.5. And because they want it to the nearest whole percent, we're going to say approximately 82% of the data is between 53 and 65. Does that make sense to you? Okay, we understand why we got 13.5. We understand why we subtracted 27 because there's 27% difference between 68 and 95 divided by 2 because we're just looking for that half of it. Okay, added onto the 68. That's going to give us that. Okay? Everybody's with me? Perfect. All right. Let's look at this next one. 5. The test scores were normally distributed with a mean of 48, standard deviation of 8. Approximately what percentage of scores lie between 32 and 56? Okay. Use the standard normal table. So let's come back over here. Okay. Again, we can leave all of that. We just need to change our numbers. So what's our mean of distribution? No, what's our mean of distribution? Our normal, what is our 48? Okay, where do I put 48? In the middle. Okay, and you said our standard deviation was 8. So what am I going to do to the right? Add 8. So 48 plus 8 is 56, 64, 72. Okay. Okay, coming back the other way. 40. 32, 24. And what are the numbers, what are the scores that we're looking between? 32 and 56. And what you should notice is that it's the same concept. It doesn't matter that it's to the left. What I'm still doing is that you're noticing that it's the whole of 68 and half of 95. So is my number going to end up being the same? Yes. Right? I should still get 82%. Right? Because it's still 95 minus 68 is 27. 27 divided by 2 is 13.5. Add that back to the 68 whole that I have, getting 82%. So we understand all of that then. Okay? All right. 6, make a stem and leaf plot for the data. This is exactly as well, stem and leaf plot. Sorry, this is a little different, not a lot different. How many of you remember stem and leaf plots at all? Okay, right, pretty easy stuff, right? So all we're doing there is we're taking our data and we're breaking it up. Hopefully if I can. So on number 6, right, you have your stem, you have your leaf, okay, because we're dealing with what, tens, pretty much, right? Start with our smallest tens, which is what, 2, 2, 3, 4, 5, and then you order your leaves, which are your ones positions, in order from least to greatest, right? So we have 20, we have 26, we have 27, we have 29, we've got 30, 34, 35, 37, 39, 40, 41, 44, 51, 52, 57. Does that make sense? Does that ring a bell on how we set up a stem and leaf based upon that? Okay? So I think you guys can handle that. I don't think that needs a ton of review. Okay, number 7 gives me some measurements here. It says using graphic calculator, find the mean and the standard deviation to find your minimum, your Q1, your median, your Q3, and your max. Use this data to draw a box and whisker plot. All right, so you have that data right there. All right. Just so that we're clear, again, I think everybody pretty well knows how a box and whisker plot works. But just so that we're clear, this first spot here is my minimum. This spot over here is my maximum. Okay, we've got Q1, median, Q3. Right? Okay. So let's go back to our data. Let's plug that in our graphing calculator. All right, we like graphing calculator days. Stat, I'm going to go ahead and clear out that list 1. Okay. All right, what do we have? We've got 653, 588, 550, 619, 571, a number that will not be uttered, 698, 714. Okay. And the reason you want to know, I mean, the big reason you want to know how to use your graphing calculator here is that we know how to find mean, but when we start dealing with big numbers, this gets to be kind of a time-consuming pain in the butt whenever our calculator can do this pretty quickly. Stat, calc, one variable statistics, right? We know our mean is 632.375. What else did it want? Standard deviation. We know our standard deviation is 56.1. Okay, which for whatever reason, 632 point, they get a little bit different number there, and I'm not exactly sure why. I don't know that I left anything out, but they say that the standard deviation was 632.5. Not really sure why their number is different there. They got a standard deviation of 60, which I'm going to go with my graphing calculator on this because I don't think we messed anything up. But let's go down and let's look at our minimum. Our minimum, let's see. Our minimum should have been 550. Q1 was 579.5. Median 636. Q3 682. Maximum 714. So all our information there looks to be pretty good. And I think that the deal that they got different, how they got 60, is that they're actually looking at this number here, but this is our standard deviation, so. All right. Any questions on that? No? All right. Something that I didn't get into for whatever reason, I forgot to put it in. And so you can write this down if you want. This is actually the last 2 questions in here. Should have been part, but I don't think it got sent in with your notes. Is solving these. So let's see if we look at this. This is abstract coefficients. This is just solving a system of 2 variable linear equations, which is not hard. Especially when you consider that we can solve this through elimination, right? My y's will cancel out. So if we just simply add here, right? That's going to give me 5x equals, what's negative 40 plus 15? That's what I thought, negative 25. All right, divide by 5. X equals negative 5, correct? What do I do once I have x equals negative 5? Plug it back into one of these. I probably plug it into the easier of the 2. So we got negative 5 plus 4y equals 15. Add 5 to the other side. You got 4y equals 20. What's y equal? 5. So your coordinates there are negative 5 and 5. Okay, easy enough to do. Right? It's really kind of funny, I think, with Algebra 3 and Saxon math. You'll go from like really complicated stuff back down to really simple middle of the year Algebra 2 stuff. So it's just kind of how it is. Number 10 might be a little bit more involved. Okay, but still really not all that bad. Total cost of production varied linearly with the number of items produced. So this really just kind of comes down to knowing how to write the equation for it. When 29 items were produced, the cost was 810. What you want to understand is that cost is going to be your y. It's still written out in y equals mx plus b form. So your cost is 810. 29 items produced is your slope. Okay, so you got 29. Or really that's your x. So it's like m 29. Let's see. But you don't know what your b is. You don't know where your y intercept is. So that's what you have for that. And then when 23 items were produced, okay, the cost was $690. Okay. You still have plus b over here. Okay, so it's going to ask for this. And the book gives a really complicated way of solving this. It's a lot easier. For whatever reason, they try to solve m first. But one of the things that we can do, or they try to solve b first, I'm sorry. The easier thing that we can do is cancel out our b's, right? Because in these equations, b is always b, right? Which means it'll always cancel out if I subtract the two equations, right? So these are going to cancel out, and then I can just subtract. So what's 810 minus 690? 120. All right, and 29 minus 23. 6. All right, so divide by 6. Right, solve for m. What is m? 20. So m equals 20. So now we can plug that back in and solve for b and get the rest of our equation. So if we come over here, we've got, let's say we use the 690 just because it's kind of smaller. We've got 20 times 23 plus b. What's 20 times 23?
460.
460. What are we going to do with 460?
Subtract it to 690.
Subtract it from 690. All right, so minus 460.
230.
All right, so we got 230 equals b, which means my equation can be written out as y equals, we know we're going to get 20, so y equals 20x plus 230. Right, now they're going to end up asking me to not only solve the equation, but to find out some new bit of information. So we want to find out what it would cost if 100 were produced. So we're going to end up plugging that 100 in where? At the x. So we're going to do y equals 20 times 100 plus 230 to find out what that cost would be. So 20 times 100 is going to be 2,000. So it should end up being 2,230, right? All right, so. All right, anything in there too difficult for us to do? I don't think so. I think this is less, and I think you guys can get this done. So I'm going to hit stop on the video right here and let you guys get started.